Welcome students. So let me continue the same unit 10 types of chemical reactions. In the last video we had seen types of chemical reaction and the introduction part. What we are going to see today, that is classification based on the direction of the reaction. So direction of the reaction means how the chemical reaction will show the changes from forward or backward. So let me see what are the classification. And see, in the previous classes we had discussed the physical changes and chemical changes. Physical changes means only the physical state, maybe the solid is converted into liquid or liquid is converted into gaseous part. So the changes will be happen in the physical state. That reaction somehow it will be reversed. Reversed means, we see the example. If you take the water, if you freeze, it will change into ice cube. If you melt that ice cube, it will convert it into liquid. So these changes will be reversed. But in chemical reaction, most of the reaction not able to be the reversed reaction. But very few reactions only will be reversed. So let us see what are the types of reactions, chemical reactions based on the direction. One is a reversible reaction and another one is irreversible reaction. So what is the meaning of reversible? Reversible means if the reaction has to take place in the chemical based means chemical reaction, that the reactants can be converted into product. And simultaneously the product is reversed as a reactant. So that is called a reversible reaction. For example, if you are taking the mobile phone, for example, mobile battery. So if you plug that mobile battery through charging means that the lithium, what battery inside, that is lithium. So that the lithium will suck that electricity and store it. When we use the mobile phone, the battery will be discharging. Once charging, again discharging. Again you have to charge it, discharge it. So this reaction is reversed. So this will happen. See that lithium is a chemical reaction has to be taken place in that battery. So this is the example for reversible reaction. So how I have to represent that systematic or schematic or syntax of this reversible reaction is A, B is a compound or some product or some reactant. If you take this reaction under the reversible reaction means it can be split this compound or this reactant into product as two. So product AB is split into A and B. If you take any reactant, it can be split into. If you take so let me see the example of the reversible reaction. Reversible reaction means phosphorus pentachloride. This can be split into phosphorus trichloride plus chlorine. So this is the reversible reaction. Like simultaneously these two products can be simultaneously changes into the reactant. So these initially that reactant is slowly it will converted into product. At one of the stage, this reactant and product, this is equal. The reactant is converted to product, simultaneously the product is converted into reactant. Like that, that state is called in equilibrium. That reaction state is in equilibrium on final state. Initially it is not in equal. So that is the example of reversible reaction. So this direction should be representing both sides. One is forward direction, that means the reactant converted into product, that is forward directly. That product is converted into reactant, that is the backward direction. So both direction we have to represent in the reversible reaction. If you go for irreversible reaction, we know that most of the chemical reactions are as irreversible reaction because once the reactant can be converted into product, it never come back to reactant position. So let me see the example. If you take a wood or coal, whatever you have, if you burn that wood or coal, it will react with oxygen to form a carbon dioxide. So coal if you take and oxygen, if you combine this, it will form as a carbon dioxide plus heat. It never come back to the reverse position. So that is the irreversible one direction. So it will return back, it won't return back. So that is the irreversible reaction. Most of the chemical reactions are irreversible reaction. So this is the classification of chemical reaction based on the direction. Whether the reaction is under unidirectional or bidirectional. So that is the classification. Let me see the differences between a reversible reaction and irreversible reaction. So what is the differences? First, if you take that the chemical reactions must be reversed, but in irreversible reaction cannot be reversed. If you go for the second difference, both the forward and the backward direction has to take place simultaneously. Both the reaction has to take place simultaneously in reversible reaction, but only unidirectional has to be taken place in irreversible reaction. See, it attains equilibrium. On stage it attains equilibrium, but it not attain equilibrium in irreversible reaction. And reactants cannot be converted into product because that product simultaneously the product is converted into reactant. So reactant cannot be converted into product, but in irreversible it is a unidirectional reactant completely converted into product. So that is the one differences of irreversible reaction. And in reversible reaction, the reactant slowly converted into product, but in irreversible reaction it will take fast to convert the product. So that is the differences between a reversible and irreversible reaction. So let's see, we have seen that irreversible and irreversible reaction, but we have to know how much time or how much speed it will take to convert from reactant to product. So let me see the rate of a chemical reaction. The rate means speed. What is the meaning of speed or timing? How much speed it has to convert from reactant to product? Let me see. See, consider if you take A is a reactant, it will convert it into product. Okay. See, I have 100 gram of reactant. It will take 1 hour time to convert as a product, but 50 gram only it will be converted to product. Remaining 50 gram it will be left in the reactant. So slowly it is converted. Only 1 hour, only 50 grams only it is converted into product. I consider another one reactant. It will be B is a reactant. It is converted into product. The same 100 gram, same 1 hour, 80 gram of the B reactant is converted into product. Remaining 20 gram is left out. So how you have to compare which reactant is more faster? Definitely is a B reactant, because in the same 1 hour from 100 gram, 80 grams is converted into product. Remaining 20 gram only left. So the like way we have to conclude that, or we have to know that, we have to observe that which reaction is faster. So that is the rate of a chemical reaction. So I have given two examples. One is rusting of iron, another one is burning of petrol. Rusting of iron means it's a chemical reaction. So if you place an iron pieces in an open place, this iron will react with oxygen to form a rusting. So iron oxide. Suddenly it won't take that formation. It will take slowly it will changes their chemical reaction. So it will take long time to react to, that is the speed or that is the time of a chemical reaction. But burning of petrol means if I started to to drive a vehicle, then petrol has to take chemical reactions to drive a car. So that reaction is suddenly it has to take a not very long time to convert the chemical reaction. So that burning of petrol has to react as a chemical reaction is a very short time, but rusting of iron it will take long time to convert iron to rusting. So like that you have to compare the speed or time of a chemical reaction. So I think you have to know the definition of a rate of chemical reaction. What is that? Change. Change in the amount or concentration. Amount or concentration in any one of the reactant or product per unit time. So time is definitely compared with the concentration of reactant or product. So why we rate is speed or time, how much time it will take to convert from reactant to product. Suddenly it will convert or it will take long time to convert the reactant to product. So time is very much important for this rate of chemical reaction. Every chemical reaction we have the time, we know the time, how much time it will take to convert from this reactant to product. So time is very, so amount or concentration of any one of the reactant or product per unit time. So that is the definition of rate of reaction. So see, let me consider one example. A is a reactant and B is a product. Okay, how you have to consider, how you have to express in the rate of chemical reaction, that is rate is equal to minus of D. D means change. Here we have to mention it as no change, differentiation. So change, what is the meaning of square bracket? That is concentration of A. Concentration of A with unit time is equal to plus change in B with unit time. So dt. So why we put that sign negative in concentration of A and why we put a positive sign in the concentration of B? Because see, negative means that A will decreases its concentration because the A is continuously converted into product. So it will decreases its concentration, but B is getting the product, so it will be increasing the concentration of B product, increasing. So that only we have mentioned this negative sign and positive sign. Negative means decreasing, positive means increasing their concentration. So square bracket, so that is I have mentioned here, minus sign means decrease in concentration of A with time, positive sign means increasing in the concentration of B with time. So that is the expression of the rate of chemical reaction. So next topic is factors influencing the rate of a reaction. So already we know the rate, what is the rate of reaction. So rate of reactions means that the change or concentration of the reactant in according to with the timing. So the rate of the reaction, what are the factors are influencing to speed up the reaction? So what are the factors? So let me see 6 factors over here. One is nature of reactants. So first thing, the reactant's nature. See, I have given one example, that is sodium reacted with both hydrochloric acid and acetic acid. But if the sodium is reacted with the hydrochloric acid, means it will take less time to get that product. But the same sodium is reacted with acetic acid, means it will more time to produce that product. So reacted that, so which one will take very less time? That is the speed of reaction. So that is the nature of reactants. Nature of reactant means those reactants which speed up the chemical reaction. Second factor is concentration of reactants. Concentration of reactants means if you add more reactants means it will increases the rate of reaction. See, for example, if zinc, you have to take zinc is a reactant and it will react with hydrochloric. So hydrochloric, if you take less amount means it will take long time to get the product. But if you take more amount of hydrochloric acid means it will react rapidly and we will get the products. So that is the concentration of a reactant. We will give more concentration, it will speed up the reactants. The third factor is temperature. So temperature means if we give the temperature, ordinary at the room temperature, it will react, but it will take long time. If we give the extra temperature or extra heat to the reactant means it will speed up the reactants and it will get the product. So temperature is also one of the factors which influences the rate of chemical reaction. So here calcium carbonate. Calcium carbonate is reacted with hydrochloric acid at room temperature also, but it will take long time. So what we have to do, if we give the temperature or heat, if we supply to this reaction, means this reaction will speed up and we will get the product. And the next factor is pressure. Pressure means, consider if you have the reactor as a gases. So the physical state in gases means, if you increase the pressure of the gases means, definitely the reaction rate also increased. So that the reactants, if it is gases means the pressure, it will increase the speed of the chemical reaction. And catalyst. What is the meaning of catalyst? Catalyst is also one of the substance. Why we need catalyst to speed up the reaction? See, for example, potassium chloride is normally it will decomposes into potassium chloride and oxygen. Normally it will happen. But if you add any catalyst to that substance means the catalyst will induce that reactant to that the reaction rate will be increased. The speed or time will be increased. So the product will get at the time itself. So catalyst is a substance. Here what catalyst we are using to include this reactant, that is manganese dioxide. So manganese dioxide is a catalyst which speed up the chemical reaction. And the last factor is surface area of reactants. What is the meaning of surface area of reactants? If reactant is a solid. Solid means if it is reacted with the acid, it will take the time to react, it will take long time to react to get the product. But if you take the same solid as a powdered form, it will increase the surface area and also it will rapidly increase reacted with the hydrochloric acid. So that we will get the product directly we are increasing or what we have to say, that is at the moment we have to get the product. So surface area, that is the powdered, if that reactant is in the powdered form, that also will be reacted or that also will increase the rate of reaction. So these are all the factors which has to be increase the rate of chemical reaction. So from this video what we have learned, that is the direction of reaction. Direction means reversible reaction or irreversible reaction, and rate of reaction, that means how that reaction will speed up, and what are the factors which influence the rate of chemical reaction. So we have 6 factors which has to be speed up the chemical reaction. If you are seeing all the 6 factors, only that the main concept, that is the hydrochloric acid is readily reacted with all the reactant product, but it will take time to react. So some of the factors which induces the speed of the chemical reaction. Thank you, students.